And now we finally get to the third method of solving simultaneous equations, and that is addition. Now, some people call it elimination. I don't like that word because everything we do is elimination. As a matter of fact, if we're trying to get everything down to one variable, and most of what we do in algebra is getting everything down to one variable, what are we doing? We're eliminating all the other variables. So I don't think elimination is very descriptive, but just so you know, you will hear that. Addition seems to be more appropriate. So let's, substitution is usually the best way to solve for simultaneous equations. But sometimes you get into a situation where addition makes the most sense. And that would be true here when we have a negative 4y and a positive 4y. So what we would do is add the two equations together. 3x and 5x is 8x. Negative 4y and positive 4y is 0. And 8 minus 24 is negative 16. So without any substitution or anything, we just very easily got rid of our y. So that seems like a good way to handle this particular equation. That is to say, when you're handling simultaneous equations, you're going to have to make the decision quite often. The book will often tell you we want it done this way or we want it done that way. But if you're on the SAT or ACT or something like that, you're going to be solving it any which way you want. And so you're going to have to look at the equations and see what's the easiest way to do it. Now, usually that method is going to be substitution, but as you can see here, this was real simple. And now we just have to isolate our x. There you go, 8 over 8 will isolate that x, and negative 16 over 8 is negative 2, so x equals negative 2. Let's see what y equals. And the best way to do this, now we can eliminate x the same way through addition or subtraction, whichever way you want to look at that. But at this point, the easiest thing to do is substitution, and that's usually what we do. We don't have to, but that's usually what you do with addition, is for the second variable, you use substitution. Now, like we saw with substitution, you can use either equation, the first one or the second one. And the first one seems to be a little bit simpler, not a lot simpler, but a little bit simpler than the second one. So that's the one we're going to use. And so we're going to insert negative 2 where the x is. So we're going to multiply 3 times negative 2. 3 times negative 2 is negative 6, and let's get that negative 6 on the other side. Bring all that down. Divide both sides by negative 4. That isolates our y. And y equals 14 over negative 4, but that can be reduced to negative 7 halves. And so our answer is negative 2, negative 7 halves. And that is the point at which these two lines will cross. And let's try another problem. Okay, in the last problem that we did, we had two variables that were the same, actually opposites, negative 4y and positive 4y. We don't have that here. We have negative 6 and positive 2. We have 5 and we have 3. So the way we do this is we multiply one of the equations until it's equivalent, opposite but equivalent, to the other one. And now 3 and 5, we'd have to get those up. We'd have to multiply this times 3 to get that up to be 15. We'd have to multiply this times 5 to get it to be 15. But here we can leave that negative 6 alone, and if we multiply this equation by 3, we're going to get that x to be 6, so that's going to be 6x minus 6x. That will eliminate our x's. And we'll just multiply out everything else. That's going to be 9y. And 2 times 3 is going to be 6. So let's do that. So there you go. We have a variable that's opposite and equal. We have 6x and negative 6x. So we're going to add those two together and get 0. And so let's bring everything else down. Well, that's good. 14y equals 28. Let's isolate that y. Okay, 14 over 14, we'll isolate that y, and 28 over 14 is 2. Y equals 2. And our simplest equation for substitution is the second one before we multiplied it out. Let's bring that down again. Remember, it was 2x plus 3y equals 2. And so we know the value of y, it's 2, so we're going to substitute it in there. 3 times 2 is 6, so let's get that 6 on the other side. Bring all that down. 2x equals negative 4. Let's isolate that x. There we go, and negative 4 over 2 is negative 2, and x equals negative 2, y equals 2. And our point of intersection is negative 2, 2. And let's try another problem. Now, if you look at this problem, there's nothing I can multiply 2x times to get to 3x. And there's nothing I can multiply 6y times to get to 9y. So in a problem like this, I'm going to have to multiply both equations. Now, Mr. Wallace does this. He thought that y was simpler. So he turned 9y into 18y and 6y into 18y, multiplying this by 2 and that by 3. I didn't see that as simple. And you can do it that way. As a matter of fact, when you look at all these things, there's several ways to solve these problems, so you have to use your noggin a little bit. But to me, if I multiply this times 3 and that times 2, I'm at 6x, and 6x to me sounds simpler than 18y, and that's my opinion. But let's do it my way. I'm putting my multipliers on the right-hand side of the parentheses. As you know, they're usually on the left-hand side of the parentheses. And I'm doing that for 2 reasons. Number one, I'm running out of room here, and I want you to be able to fully see what we're doing. The other thing is, I want you to see for the future that if something is on the right-hand side of the parentheses, it's the same as the left-hand side. We multiply it out. So that 2 times 3x is going to give us 6x. That 3 times 2x is going to give us 6x. So that's going to be a number that we can work with. So let's multiply that out. Let's multiply the top equation out first. Okay, I want you to really examine that. The top equation, we distributed the 2 throughout the entire equation, and that is what we got. Now let's distribute the 3 throughout the entire equation here. There you go. We got 6x and 6x, and if we add those together, that'll be 12x. That's not helpful. No, we're going to have to turn one of those 6x's into a negative 6x. And so we're going to have to multiply one of those equations by negative 1. That is to say, we will change the sign of every term in that equation. So which one do you want to do? Well, normally we do the bottom one, right? But if we do that, we're going to end up with a negative y, so I don't like that. And why don't we do the top equation, and we're going to have our negative number on top. And I know, since the first grade, we've liked our negative number second, but, again, we're in high school now, so if our negative number is on top, that's just fine. So let's multiply everything up here by negative 1. That means we're going to change the sign of everything. The 6x is going to be negative. The 12y is going to be negative. And the 18 is going to be positive. Because it's negative right now, it's going to be positive. Okay, so we're going to bring all that down. But this got a little complicated, so why don't we bring it down one term at a time. Let's see, negative 6x and 6x is 0. So we're not going to bring that down. And negative 12y plus 27y is going to be positive 15y. Let's bring that down. Well, that looks good. And positive 18 and negative 78 is negative 60. Let's divide both sides by 15. That'll isolate that y, and negative 60 over 15 is negative 4. Y equals negative 4, and let's substitute that into the simplest equation. I think the simplest equation is the first equation. Good, and let's substitute that negative 4 into the y right here. 9 times negative 4 is negative 36. Let's bring that over. Bring all that down. Divide both sides by 2. That isolates our x, and 10 divided by 2 is 5. X equals 5, and our point of intersection is 5, negative 4. Let's try another problem. Sometimes you'll see problems like this where equation 1 is just fine, x, y equals units, and now we have y units equals x. Can't have that. Now you really want x plus y equals units. You don't have to, but one thing you do have to have is everything lined up. So we're going to get our units over here, and we're going to get our 5x, our negative 5x over here. Bring all that down. Add positive 5x to the x. Bring all that down. And let's get our x and our y to trade places. Good, that's the way we want it looking. And let's bring our first equation down. This is our second equation, if you remember. Let's bring our first equation down. And good, that's set up for the addition process, the elimination through addition. And we're not going to do that because we've already done it several times. However, let's look at it real quick. What do you think is the easiest variable to eliminate? We got 2 and 5 there, and we got 3 and 5 here. I know it's negative 3 and negative 5, but anyways, that's going to give you 15. That's going to give you 10. What do you think is easier to deal with? 10 is always going to be easier to deal with than 15. So why don't we multiply the first equation by 2, and we'll multiply the second equation times 5, and we'll eliminate that way. But we're not going to do that. Let's look at another problem. Okay, I think you can see that if we multiply the 2x by 3, we're going to get 6x, and 6x minus 6x is going to be 0, so that's a good way to go. So let's distribute that 3 throughout the entire equation. Okay, and look at that. We got 6x, negative 6x, negative 15y, positive 15y, positive 9, negative 9. We have the same exact equation, except the signs are different. Now the first thing we can do is we can add these two equations, and that's going to be 0, 0 equals 0. Or you don't even have to do that. Just, if you multiply this top equation or the bottom one, it doesn't matter, by negative 1, we're going to have what? We're going to have negative 6x up here, same. We're going to have positive 15y here, same. And we're going to have negative 9 here, same. So what do we have? We have the same line. What does that mean? That means we have an infinite number of solutions. When we have the same line, we have an infinite number of solutions. Now let's look at a similar problem. Okay, our lowest common multiplier for 6 and 4 is 12. So we can multiply that times 3, and we can multiply that times 2. And our lowest common multiplier For y, 6 and 9, that'd be 18. So we can multiply this times 3 and that times 2. I think 12 is simpler, don't you? Well, I have something that's even simpler. Look at these two equations. They're both divisible. Now the first one is divisible by 2. Let's divide all these numbers by 2. Yeah, and if we divide that first equation by 2, we'll see that we have 2x minus 3y equals 4. There, that's a lot simpler. And I'm teaching you a method that most people don't use, and if you don't find this method simpler, then please do it the way the book is doing it. But let's look at that second equation. We got 6x, 9y, and 15. Wow, all those are divisible by 3. So let's divide all of that by 3. Yeah, and if we do that, that'll be 2x, that'll be 3y, or negative 3y, and that'll be 5. So let's do that. Okay, that's a lot simpler, and boy, our x's are the same, and our y's are the same. Our unit values are not the same, so what does that mean? If our x is the same, the coefficient for our x and the coefficient for our y, if they're the same, that means we have the same slope. Now what does that mean? If we have the same slope, we either have the same line, which would be an infinite number of solutions, or we have parallel lines, which would mean we have no solutions. Well, this is going to be our b. This is going to be our y-intercept. We're not going to reduce this to y equals mx plus b. We don't need to. All we need to do, we don't need to know what the slope is. We just need to know that it's the same. And if our coefficient for x and our coefficient for y are the same, then we are going to have the same slope. I know I'm repeating myself, but I'm trying to make this simple. But even though we have the same slope, we don't have the same units value, which means we're going to have a different y-intercept. And we're not going to worry about what the y-intercept is, just that it will be different. And if we have a different y-intercept, what do we have? We have parallel lines. Same slope, different y-intercept. That means parallel lines, which means we have no solution. And so these last two problems that I showed you are just, you're going to get into that every once in a while, and instead of being confused that 5 equals negative 4 or 0 equals 0, just know that they are either parallel lines or they are the same line. And we already went through how to handle that. And we are going to do homework. And we're going to skip the next lesson. I believe the next lesson is lesson 4. That is lesson 4.4. And we're going to skip that because that's an Algebra 2 type situation. So we're going to skip that and go straight to 4.5.